This application is being performed using American Beauty resistant soldering equipment in order to overcome the severe heat sinking properties that are often encountered when soldering bus bars or large heat sinks to printed circuit boards. The bus bar has been placed on the board and properly aligned and is temporarily being held in place against a squaring block using a large clamp. In preparation, the bus bar is being securely tack soldered at multiple locations along its length so that the securing block and clamp can be removed, giving an unobstructed path along the full length of the bus bar for the final soldering application. By allowing a sufficient amount of space between the tack soldered sections, we are able to ensure that the bus bar will remain securely in place throughout the soldering process. Because of the localized heat of resistant soldering, it is highly unlikely that multiple tack soldered locations would reflow simultaneously, allowing any unwanted movement. We can now position our return harness at one end of the bus bar, and with the fixturing materials removed, we can begin our actual soldering process. Starting at one end of the board, we will now begin soldering our first section by melting an appropriately sized rosin core solder wire along the seam between the bus bar and the circuit board trace. Now that we have melted solder along the seam, we are reapplying heat to this section in order to reflow the solder. This will allow the natural capillary action of the liquid solder to wet more deeply into the joint. Performing the resistant soldering process in the manner that is being presented here will not only strengthen the mechanical integrity of the joint, but the deep saturation and thorough wetting of the solder will also ensure that we will have excellent electrical conductivity along the full length of the bus bar and printed circuit board connection. With the current return harness attached directly to the bus bar, we are able to produce the heat that is required to melt and flow solder at any location along the seam. And as you can see, the heat that is being generated by this process originates directly where the carbon electrode is in contact with the bus bar. The temperature levels that can be produced with resistant soldering equipment far surpass the operating temperatures of most standard conduction irons. And although there are torches available that produce comparable temperature levels, a flame will spread out, lacking the physical characteristics required for truly localizing the thermal energy that is produced. By rapidly achieving the required solder melt temperature within the joint, we shorten the amount of time available for heat to travel beyond the area where it is required. This minimizes the potential for thermal damage to heat-sensitive components, laminates, and other materials in the surrounding area. This ability to produce, control, and direct a significant amount of heat specifically where it is required should make resistant soldering your method of choice, especially when you are trying to overcome the high heat-sinking properties of applications like the one presented here. You will find videos relating to other soldering methods by visiting us online at AmericanBeautyTools.com.